Assalamualaikum. We are Group 4 and today we will be presenting our engineering math assignment. The topic assigned to us is metric inversion method 3 by 3 from set C, and the question we have chosen to present is question number 2. Before we begin, let me introduce my group members. My name is Aina Kastina binti Zabri. This is Amy Nur Damia binti Mak Daud, and the last one is Nur Hanifah Hazwa binti Muhammad Hasidan. Now, let's move on to the question. First, we will read the question. A herb farmer keeps track of the water given to 3 herb types: basil, mint, and rosemary. The amount of water used on each day is recorded for each herb. After 3 days, the farmer knows that the total water used for each herb, but he forget the exact use for each day. Now, let's read the table. For basil, day 1, 6 liters, day 2, 3 liters, day 3, 5 liters. For mint, day 1, 4 liters, day 2, 6 liters, day 3, 2 liters, and the last one, rosemary, day 1, 2 liter, day 2, 1 liter, and day 3, 3 liter. The total amount of water used for the herbs over the 3 days was 83 liters for basil, 70 liters for mint, and 37 liters for rosemary. Question 8. Write the given information as a metric equation of the form A times X equal to B. So, we will proceed with the solution step by step. First, we create the matrix form of the equation. The first bracket represents the coefficient of each variable taken from the table. Each row shows the water usage for basil, mint, and rosemary on each day. The second bracket represents the unknown variables, which are x1, x2, and x3. This refers to the amount of water used on day 1, day 2, and day 3. The third bracket represents the total amount of water used for each herb over the 3 days, which are 83 liters for basil, 70 liters for mint, and 37 liters for rosemary. So this matrix equation is compact way to represent the 3 linear equations.
The next question is, calculate the inverse of matrix A. Show your working for the determinant and adjoint matrix before writing the final form of adjoint. As noted on the slide, if the determinant A equals to 0, the matrix is singular and has no inverse. For matrix A, we have the element shown here. To find the determinant, we expand along the first row. By calculating the minus and applying the sign, we get 6 in bracket 18 negative 2, negative 3 in bracket 12 negative 4, plus 5 in bracket 4 negative 12. This gives us a final determinant value of 32. Since it is not 0, we can proceed to find the inverse. The next step is to find the cofactor matrix labeled as matrix C. To do this, we must find the determinant of the 2 by 2 minor for every single element in matrix A. As you can see in the diagram, we follow a specific pattern of sign, plus, minus, plus, and so on. To find the first element, we cover or ignore the first row and first column. Then, copy the remaining element into a 2 by 2 grid. We repeat this process for all 9 positions, ensuring we multiply each result by its corresponding sign from the checkerboard pattern shown on the right. Now, let's look at the actual calculation for our cofactor matrix. By solving 2 by 2 minus, for example, 6 times 3, negative 2 times 1. For the first position, we derive the individual's values. After performing all the subtraction and applying the negative sign where necessary, we get our complete cofactor matrix C. The values are, in the first row, 16, negative 8, and negative 8. Second row, negative 4, 8, and 0. Third row, negative 12, 8, and 24. Please double check your sign here as this is where most mistakes happen. Finally, we move to the last page for my question. We must find the adjoint of A, which is the transpose of our cofactor matrix. This means we turn the first row into the first column, the second row into the second column, and so on. Just repeat the process. Once we had the adjoint, we substitute everything into the formula. I already gave it in the yellow box. By dividing every element in our transpose matrix by our determinant, which was 32, we arrive at the final inverse matrix shown at the bottom. This completes the process of finding the inverse of matrix A. That's all for me. Thank you.
Okay, next for part C, we use the formula X equal to A inverse B to determine the amount of water used each day. First, the inverse matrix A inverse was multiplied by matrix B using the row and column method. For the first row, the calculation is 16 times 83 plus negative 4 times 70 plus negative 24 times 37 equal to 160. For the second row, negative 8 times 83 plus time plus 8 times 70 plus 8 times 37 is equal to 192. For the third row, negative 8 times 83 plus 0 times 70 plus 24 times 37 equal to 224. All these answers are then multiplied by 1 over 32. So we get 160 divided by 32 is equal to 5. 192 divided by 32 is equal to 6. And lastly, 224 divided by 32 is equal to 7. Therefore, the final matrix X is 5, 6, and 7, which shows that the water usage for the 3 days was 5 liters, 6 liters, and 7 liters. That's all from us. Thank you for your time. This presentation is based on 3 references which are listed in this slide.